Action.
Okay. So what we're going to talk about right now.
Introduce yourself first.
Okay. My name is David Foley, and I'm the Petey Greene tutor here at Strive.
Excellent.
Okay. In Lowell. And what we're going to talk about right now is the difference between a polar molecule and a nonpolar molecule. And the example that we're going to use is water for a polar molecule. And water has a chemical formula of H2O. And you might know or have seen pictures of it. It's known as a bent molecule. And the oxygen, and this, we're not going to get into the details here, but what holds a molecule together are the electrons that get shared between the different atoms. And it turns out that oxygen in water molecule takes electrons away from the hydrogen part, and the oxygen end of the water molecule ends up being negatively charged, and the hydrogen end ends up being positively charged, and that's why we call it polar. Okay, polar because you have two poles. Okay. Now, an example of a nonpolar molecule would be oil. The chemical constituents or the atoms that go into oil are carbon and hydrogen. There's no oxygen in it. And between carbon and hydrogen, these bonds are called nonpolar because these electrons are shared equally between the carbon and the hydrogen. So overall, the molecule does not have one end that's positive and one end that's negative.
It has an even or neutral charge?
Yes, even the water is neutral, but it's neutral on balance in total.
Right, one side has one charge, the other side has another charge.
Exactly. Now,
whereas you have a positive and negative charge flowing throughout the non-polar molecule.
In water, all of the molecules of the different water molecules will all orient themselves so that the positive end of one goes onto the negative end of the neighbor, and they stick like glue.
So we have the difference between the water, which is a polar molecule, and the oil, which is a nonpolar molecule. And what phenomenon does this explain that we see every day?
This explains why water and oil do not mix.
Yes.
The reason is because the water molecules stick to themselves like magic, like glue. And an oil molecule cannot get in between because the water molecules are sticking to each other.
Yes.
Okay?
They're
cannot get
cohesive.
in. Okay.
Wow.
And this is why a surfactant like the Dawn dish soap, which has, it's a molecule which has one end of it which is polar. Let's say it's got plus and minus, and another end which is totally non-polar. And without getting into the details, because I don't even know how it is chemically, but it has one end of it which can stick to water. Okay, and it has another end which is non-polar, and that can get into the oil part, and it will allow particles of oil to get dragged in and among the water because what happens is the Dawn molecules basically can stick all around this with their non-polar parts, and they can have polar parts on the outside, which can then make their way and get surrounded by water.
Yep, okay. Got it. So we also learned, can you write that word? I love that word, surfactant, on the board, and I'll teach that as part of the lesson. A surfactant. So we looked it up. Dawn is a surfactant.
Yes.
It has that quality of having one end which is we said it was polar, but one end was hydrophilic, meaning
that's the polar
water loving, friendly to water, and then one end was hydrophobic, which is meaning fear of water, or the part of it that would not want water. The hydrophilic end attracts the water. The hydrophobic end basically attracts the hydrocarbon or the oil molecule.
That's exactly
and that's why something as simple as Dawn soap breaks up the grease on our dishes, but the same basic chemistry is useful on a larger scale for cleaning up massive oil spills out of the ocean.
It's just that you probably need a lot of it.
A lot of it, right? And they probably don't use Dawn. They use like maybe a higher power or higher.
Maybe something cheaper.
Cheaper, yeah, maybe cheaper. Exactly. All right. Well, hey, Dave, thank you so much joining us at Strive for lessons on all kinds of stuff on molecules, polar, non-polar, surfactants, and all kinds of stuff. We appreciate you, Dave Foley from Petey Greene Tutoring. Okay. Yay!